A Taylor polynomial of a function is something that helps us approximate the values of a function if we only use, second or third Taylor polynomials like we're doing here. So any values we plug into the Taylor polynomial, they'll be a good rough approximation near the center, near 1. They won't be so good as far away though. Formula for a Taylor polynomial, it's plugging our center into the function plus the first derivative of the function with the center plugged into it times x minus a to the first power, and then it's plus the second derivative. Oh, so here, usually we write like this, so over 2 factorial, and then times the second derivative with the center plugged in, times x minus our center. Now this is squared, and then since we're doing the third term in the Taylor polynomial, we're going to do 1 over 3 factorial times f prime prime prime, the third derivative, x minus a to the third. Okay, so for our Taylor polynomial, for the second term, that just means we're going to plug in 1 in for a. So if you plug in 1 in here and 1 in here, it doesn't matter in the denominator, right? Because natural log of 1 is 0. I guess it wouldn't matter if we were dividing by 0, but we get out 0 for f of a. The first derivative, so this goes back to something we've done previously. You could use the quotient rule. I like to think of things in the product rule. This is the same thing as the natural log of x times x to the negative first, right? Because you can move that upstairs and make it have a negative power. So derivative of the first function, derivative of natural log x is x to the negative first. The derivative of natural log is 1 over x. So it's, in other words, x to the negative first. So x to the negative first times x to the negative first makes x to the negative second. But then power rule says you need to take the derivative of the second function, so that's a negative x to the negative second times the first function kept the same. So there's our first derivative. We're supposed to plug in our center, plug in 1 into that function. So this is 1 minus 1 to the negative second, which is just 1, times natural log of 1, which is 0. So this is gone because of that 0 part. So we just get 1 for this piece. And then for the second derivative, it's 1 over 2 factorial first times the second derivative, which we need the product rule again. So this one's nice and easy. The power just comes down, gets reduced by 1. And then here we need the product rule again. Just watch out and put a parentheses there because you got to subtract everything in the product rule. So the derivative of the first function with the second kept the same, plus the first function kept the same times the derivative of the second. So we got some terms we can combine that are alike here. We got negative x to the negative third subtracted by, this is x to the negative third. So negative x to the negative third subtracted by x to the negative third makes negative 3x to the negative third. And then this term isn't really going to matter because of the problem's choice in the center. That makes natural log of 1 becomes 0. But that's our second derivative. So if we plug in 1 into our second derivative, this is just negative 3. Oh, I'm very sorry. I forgot my x minus 1 term. I thought it looked a little light. Forgot a big piece of a Taylor approximation. There's no variable here, so how can it model the function? Sorry, the derivative with 1 plugged in is 1. And this is x minus 1. I forgot this piece. But over here, when we plug in our center, we got negative 3, so times negative 3 for the second derivative at the center, and then we need to multiply that by x minus 1 to the second. Okay, and then for the third term, well, it would be the fourth term, I guess. But for t sub 3, that means we're supposed to expand 1 more time and use the third derivative to approximate the function using a Taylor series. So that just means we're going to need to add something on here for the third term. So the third term is everything that the second Taylor approximation gives us. Third Taylor approximation just needs to know the third derivative. So this is 9 this derivative needs product rule again. That's a negative 2. Getting sloppy. So this is negative 6x to the negative 4th times natural log x. The derivative of the first, the second kept the same, plus the derivative of the second that makes x to the negative first. So these can combine, so it gives us 11x to the negative 4th. And then I'm going to save my handsome writing here because that's just the same thing. So if you plug in 1, you're going to get out 11. But then this is supposed to be 1 over 3 factorial times 11x minus 1 to the third. So this is 1/2, or you could say negative 3/2 times x minus 1 squared. And this is 11 over 6 times x minus 1 to the third. Put that all together, and that makes your third Taylor approximation.